Deepak sir, after long time.
लॉन्ग टाइम नहीं भैया, अगले आए थे पिछले हफ्ते।
पिछले हफ्ते आए थे क्या? लेकिन मुझे लग रहा है आप गायब थे कुछ दिन, एक दो सेशन।
नहीं, फोटो नहीं खोली होगी।
मे बी। चलो।
Yeah. So screen is visible.
यस यस।
Yes, you're good to go.
Yeah. So yeah, now we are starting the chapter 2, that is designing agent systems. So first we'll look at introduction to agent system design. So when we talk about designing agent system, it is very different from designing traditional software. Traditional software, here we are the one who are cooking the recipe. We know step by step execution, and also we can track. So it is very deterministic in nature, traditional software. So we can plan, like before building, we can make a very good plan, organize things, and we can start building. So that is how traditional software used to work. But in agentic system, since we don't know the solution, the recipe will be cooked by the AI. We will only be giving our intent. So it is very uncertain in nature, the agent system. We never know when AI will hallucinate. We don't know the edge cases. So in agent system, it is like we should never think big or plan way ahead. We should do rapid prototyping and build small, like accomplish small goals rather than planning big and trying to make something big. So that is how agent system so we should build, because agent systems, unlike traditional software, they are the one who will be cooking the recipe. So they will be solving the problem. They will be doing the reasoning, interpretation, adaptation. So they deal with unstructured inputs, ambiguous instructions, and dynamic context, and it is highly uncertain in nature. So whenever we are working with foundation models, it's all about always we have to do testing in the real time itself. So it is rapid prototyping. So the development approach we should follow should be rapid prototyping, because we don't know the edge cases. We don't know when the model might fail or it might hallucinate. We don't know the performance bottlenecks also, because it is very uncertain in nature. So it's good that we should just dry run. So test ideas immediately. So we should build a prototype, test it, and if it is working, we should scale it. So that is how, so this is called as iterative design. And it is different from agile. Agile also, like we build some features, sprints, then we keep on evolving, but it is very different from that. Iterative design we should follow when we are building agent systems. So that's the idea. So the good thing is that for building agent systems or agentic AI applications, we need a foundation model. So API keys we need for a foundation model, that can be OpenAI, GPT model, or Gemini, that very easily we can get. And with that in place, and with some tools like a framework like Agno or LangChain, we can very easily start building agentic AI systems. So we can start with a vague problem, rough idea, and we have to follow the iterative design, wherein we should keep on testing. So we will build a prototype, we'll test it. If it's working, we'll keep on expanding, observing, adjusting, and the cycle will go on. So for agent systems, real world testing is part of the design process, not a final step. Because in traditional softwares, first we used to build it completely, then testing comes after development, like a big system. But in agent system, we have to keep on testing as we are developing. Because this experimentation, it will help us in checking whether we are going in the right direction, we are accomplishing our goal, actual accuracy. We will get to know latency bottlenecks, cost bottlenecks. Cost bottleneck is a very big critical issue, because if we are using a good foundation model, tokens we are consuming. So cost bottleneck plays a very big role. So there was a saying that by 2027, most of the agentic AI applications they will not be able to survive because of the running cost. Hallucination risk, we will be able to determine like where our model is hallucinating, so we can work on that. User friction points, so all that we can determine. So this is the power of iterative cycle, and that is what we should follow while designing agentic system applications. Now, the one more very important consideration is concrete use case. The goal should be very well defined. It should be specified, because if the goal is abstract, like if the goal is like vague, build an AI assistant, automate support, improve productivity, it is too vague, then AI, it might drift away from what we are looking for. It might happen. So, if we talk about the system design, so we should have clear input and output in mind, that this is what we want to achieve and this is what the output we are looking for. Success criteria, we should be very clear about, like how we will measure the success, and capabilities, like whatever agentic AI solution we will be building, what capabilities we should have. So a well-defined problem, that is very important, because here we are not the one who will be cooking the recipe. We will be just giving our intent. So that should be very crisp, very specific. So it should be well-defined. So a well-defined problem, it constrains the design space. It clarifies requirements. It allows measurable evaluation, and it reduces complexity. It's very important. So ultimately, we will get a clear solution out of the LLM. That's the idea. Okay, so in the book, this e-commerce example was given. We will discuss it in some good detail in this lecture flow. But if we just look at an overview, so if we look at e-commerce support agent, so we are trying to build a agent which will read email sent by the customer. So customer will send an email, and that email will contain a request. That request can be cancel order, refund item, or update shipping address. Now agent will receive that email, it will read what is there in it, and based on that it has to perform the specific action. If cancel order is there, agent must cancel the order. If refund item is there, agent must refund. If update shipping address is there, agent must update shipping address. So now how agent will work is, it will read the request, the email, it will identify the intent, what exactly the customer wants. Then it will retrieve the order data. It will choose correct tool, because if it has to cancel order, then it has to call that API or that function to cancel the order, and it will execute the tool and send confirmation. So agent will automate this entire workflow. The key learning for us is, it is well defined, like all the steps are well defined, like how agent should act for this particular use case. So that is what we are looking for. Grounding design in a concrete use case. Okay. So now two very important points we should take with us. First is the iterative design, wherein we should follow rapid prototyping. We should test, and if things are working, we should scale up. That's the idea. And concrete, like well-defined problem. So what is the benefit of starting small? So if we focus on small scopes, faster development we will achieve, easier debugging, that's very important, because in agentic AI system, debugging can be a very big challenge, because here we don't know the solution, how AI solved the problem. We don't know the reasoning AI did. So AI is something called as like a black box. For that, like a separate field is there. We call it explainable AI. So that is like a very useful thing. We want a good transparency, like how AI is taking decisions and all that. So that will help us in debugging that where AI made mistakes, so that we can do the correction. debugging. But smaller scope will help us in easier debugging, clear evaluation, quicker return on investment, because we are getting the results. Okay, this is what we wanted and agent is doing that. And simpler architecture. So that is what we have to follow. So whenever we are building agentic AI applications, iterative design is the key. Okay, so now let us look at our first agent system. So what we will be building in our first agent system, we will be identifying, okay, so we will be like automating that, the example which we saw, email workflow. So whenever we are building any agent, the most important part is identifying the automatable workflow slice. Like we have to find what we are trying to automate. And automatable workflow, what it is something, some task which is repetitive in nature, which occurs frequently, which follows recognizable patterns, which produces structured outcomes, and which consumes human time unnecessarily. So the idea is that any repetitive task which human is performing, that very easily we can replace it with an agent. This is a very big observation, a good insight. Like in our workplace, wherever a repetitive task is being performed by humans, we can replace it with agents. So a task, a workflow which occurs frequently, and it follows a recognizable pattern, like a routine thing is there. It's not like every time we have to do something new. So like a new creativity is not involved, and it produces structured outcomes, and that can very easily be automated, like agents can perform that. So that's the idea. Now so this is very important to identify the automatable workflow, because whenever we are designing the agent, we have to identify the workflow. So the output should be very clear, clear input, clear output. So whatever agent we are trying to build, we should be very clear that what data it will receive, what output it will give. We should have a clear picture in mind what we are expecting from the agent, and the actions has to be finite, because a goal is there, we have to reach the goal. So limited tool set. eh, So using a limited set of tools, we should accomplish the goal. That's the main idea. And there should be some metrics to measure the success. So incorrect, correct. So that's the main idea. Now we can take an analogy of a hospital. So like let us suppose we think that, okay, I'll automate the entire hospital using agentic AI. That's a wrong approach. Rather than trying to automate the entire hospital, we should take a small scope and automate that first. So start with appointment booking. One small thing I accomplished, then I can look for more workflows. So this is the idea, a small scope, a automatable workflow, a slice of it, I automated it, and the another slice, like that. I can keep on automating the entire stuff. So that's the mindset we should have while building agentic AI applications. Now let us look at one example, customer email handling agent. So the same example just now we saw, now we will see it in more detail. So customer support emails for an e-commerce platform. So the human workflow will be, so first that email we already saw, customer will send an email. That email might include refund a product request, cancel an order request, change delivery address request. So that email can include these three requests. Now this email, in the traditional way, human agent was responsible to handle it. So what they used to do is, they received the email, they read the message, they understand the request, and they identify the order based on some order ID or some details. Then Based on that, they will act on the request, like whatever the customer wants. Then they will perform an action, they will query backend, and they will send confirmation. All this they will do, humans used to do, to resolve the uh, query or the customer resolution. Now this takes about 2 minutes per email because human effort is involved. 2 minutes per email is involved. And now if we look at this task, it is repetitive in nature because only three main goals we are trying to accomplish: either refund a product, cancel an order, or delivery, change delivery address. It will also decide the tools, like it knows what tools are available, and that we have to tell the LLM that these are the tools at place, and LLM will then decide what to call, what, how to use the tool and all that. So that is the decision phase. So here, For example, if user wants cancellation, then LLM knows it will have to call the cancel order function. Uh, so that's the idea. So cancel order function is a tool. It's an external tool which is a function which we have only created. In that, a logic will be there which will cancel the order. Step two will be the tool execution phase. So in the decision phase, uh, this LLM, the model, it will determine all the necessary steps. Step two is all about executing the tool. So agent calls external system. Like agent will now call the cancel order function with the appropriate order ID. And then step three is the response phase. In the response phase, model will produce a user facing message. Your order has been cancelled. So this is how the tool invocation logic works in a agent system. So the important insight we should like consider, the agent is not doing everything itself. It is orchestrating tools. So agents are is equal to decision makers and tools are the one who are the executors. So here very important. See the idea is that the model is the brain. Now model is not doing everything. Model is just making the plan. Like the brain, it makes the plan, but actions are performed by our hands. Similarly, here the model it is orchestrating, like it is creating a plan. First, it is understanding the requirement. It is making action plan, and it is deciding which tools to call. So it is orchestrating, and then it knows that okay, I have these tools at my disposal, and it is just calling those tools, and tools are the one who are doing the real action. So execution is taken care by the tools and not by the model. So LLMs cannot act. LLMs can only plan. So action is taken care by the tools. So that's the idea. Okay, now we will discuss something very important: core components of agent systems. Now, any agent system we take, it will have all these components. It will have model, LLM. It will be responsible for reasoning, LLMs. It will have tools, external tools. It will be responsible for actions. It will also have memory. Memory is very important. Memory will be storing the context, the knowledge. Orchestration will be the flow or the logic, and the interface to interact with the agent. So interface, like agents can interact with other agents, agents can interact with third party tools and surrounding environment, and agents can interact with humans. So that is the interface. So an agent system is not just a LLM. When we talk about an agent, it is not just a large language model, it is more than that. An agent will also have tools, it will have a memory, it will have orchestration. It is a composite system of interacting components, and these are the components of an agent, and they are interacting with each other. So the key takeaway is intelligence comes from architecture, not just from model choice. This is a very important insight. No matter how good model you use, like you're using chat GPT, like it's very good in complex reasoning, the GPT model. Despite of that, if you are not properly using other tools, other components, you might not get good results. So intelligence, like agent, like whatever agent we are designing, it's not just about LLM. It's also equally important is the memory, the context we are storing. Memory is very important. Orchestration is very important. Tools we are using will be important. So all these components are equally important in designing a good agent system. So that's the idea. Okay, so okay, now we will be discussing all these components one by one. So first, let us discuss about model. So model selection. So choosing the right foundation model is very important. Now, see, the idea is that we should not always use a complex model like GPT. I think no one question is there.
No, Nicole, no question actually. I was having a
Acha.
thank question for Mohan on the side.
Oh, okay. Yes.
Yes, sir. So that is the Agno framework. So
Hmm.
that is we I can discuss that developed by one Indian guy. Okay, and he I can ping the link for it. Okay, just give me a
Yeah,
second.
maybe towards the end, right? If we can have 10-15 minutes, we can discuss about these frameworks also.
Yeah, yeah, sure. So yeah, Nukul, just allow me 10
Yeah, yeah,
to 15 minutes, okay, at the end. Okay,
yeah,
so I
yeah.
will cover about this framework and whatever the concept you are covering. I just came across to similar thought. The current challenges I'm facing in my project. I will just revise the whatever the concept you are telling. They are really good, and let's finish it. Okay.
Yes, yes. Yeah,
Mm.
yes. So the idea is that where model selection is very important. See, always we should not go for GPT because it's expensive, tokens are involved. It's like unnecessarily wasting resources. So we should be very sensible in choosing the model. Model selection is very important. So the core principle is there is no single best model for all agents. It depends on the requirement. So model choice depends on task complexity. If you don't want complex reasoning, choose a SLM or a simple model. There you will be saving cost. Latency requirement is also plays a very important role because these complex models they take time. Latency is there associated with them. Cost constraint. So model choice depends on task complexity, latency requirements, cost constraints, reasoning depth, and modality needs. If you need to process images and videos, you have to take model accordingly. So based on the type of the task, uh, best model type if we want to discuss. So for simple classification, we can use a small model. For classification, so we can use a machine learning model also. We don't need even LLM also. For conversational assistant, we have to use a generative AI framework. So we should go for a general large language model for conversational AI capabilities. For complex reasoning, definitely we should go for a large model like GPT. For real-time decision, see in real-time decision, latency plays a very important role. So we should go for a fast, low latency model. So that's the idea. So the engineering insight, we should start simple. Yes, yes, sir.
Yeah. So in your previous slide, okay, can you go back previous slide?
Yes.
So here, like I am encountering the similar problem. So can we
Mhm.
get some example for the when say simple classification using small model we can select that way. At the same time, you're saying SML we can take and some machine not we don't need the LLM as well, right? So
Yeah,
can you give some example that okay in this all this classification this one let's choose this model. Do you have anybody or you can give forward some example?
okay. So I can give one example like in natural language processing, if we have to do the intent recognition,
Mm,
in that this simple deep learning, this BERT, that BERT,
mm,
that model works. It's not a LLM, it's
mhm,
lightweight. It
mhm,
works. It works good, like good results you will get in intent recognition, like in natural language processing. Or
mm.
for image classification, you can use convolutional neural networks. Yes, yes,
Mhm. Okay.
CNN.
Okay. Yeah, even for I in my project that I need to intensify for intent classification I need to do, and then based
Yes,
upon that I need to do the routing. I'm doing the routing. So I was using GPT-4 mini, it was working, and I again started using GPT-5. So, but I know that GPT-5 we don't need the GPT-5, and GPT-4 mini can work. So just
yeah.
want to evaluate that part as well, that which model or another small model we can select, like that work fast, cost low. Okay, it should be very cheap and it should work fast. So just like in just needing the reading the it is not doing any reason. You just read it and tell it which criteria it is following and then do it.
Yes, yes.
Yeah, Mohan, I think Apple actually published a paper a couple of years ago. That's what actually triggered this discussion or this pattern, right?
Mm-hmm.
So, like when you're talking to Siri, or actually there are many chatbots like that now. So it decides actually whether to solve your because it has a small language model deployed on your phone,
Mhm.
or if it's a complex task, then it actually hands it over to cloud. Uh, so I'm sure this kind of classification model can be developed very cheaply just to understand what's the complexity of the question user is asking. Or maybe you first always ask the small language model, and based on the confidence score or something that it provides,
Mhm.
you decide that, oh, this was not the task for it, and then you fall back to a complex, like large to a large language model.
Okay. Okay. Yeah. Yeah. Makes sense. Thank you. So.
Also, there are these things just like API gateways, right? There are model gateways that people have built, like proxies, right? So, like application developer or agent developer doesn't worry about uh, picking the right model. It's the gateway. They have a like outbound gateway that can send requests to, let's say, multiple APIs, open API or like cloud or anything like that. And in that gateway also you can have that classifier.
Yeah, actually, I have one question regarding that one because I generally saw whenever we are doing any agent development, initially in the configuration you mention okay which model you want and what is the context size, all those things you configure that before starting the agent before developing. But the thing is, if the requirement changes, I mean for an agent requirement might be same, but do you think in design pattern they advise we can change the models for a single agent?
Change the model, you mean like
So let's say
depending on
right
the
now I'm
request?
using GPT. Next time I want to use this because at the time of configuration, generally I have seen they ask, okay, which model you want to use, how much of context, what is the this all these configurations do initially. Is there any possibility or people follow that? Okay, hey, I will keep on change model depending on my request or something like that. Is that a good design pattern or we are just not following that? We are just following a single one.
No, no, I think that's a good design pattern to select the model for the request. And anyway, it's not static always, right? Like whenever newer version of the LLM is released, you want to switch to that newer version anyway, right? So
But that case, what they do is, I mean, right now they are doing in company wide, let's say. So you can change that model. You will again reconfigure.
right, right, yeah, yeah, that's
But the example you are giving, Manoj, like somebody has a API gateway kind of thing, which will take decision of which models to be used instead of the agent taking that decision. Agent will always call that accordingly. It will be oh, this is a small task. Okay, let me use a small model or LLM.
yeah. I've seen like it depends on the maturity, right, of the platform. People generally start with using one model, and then to save costs or to be more efficient, like to provide better results,
Yeah, makes sense.
they generally
Yeah.
to using multiple models.
Yeah, so according to the book also, like when we are doing the rapid prototyping, it's advisable to use GPT only. Like first let us build something which is working. Once we have something which is working, then we can optimize it. And then we can think about optimizing the cost, introducing some more simple patterns. So that is what this book also suggests, that initially our goal is to build something which works, because in agentic application development, that's also a big challenge. We never know when AI might hallucinate something hidden, some complex edge cases we might encounter. So first, the goal is to let us build something small which is working. Then you can focus on optimizing. So that way also you can think about. So engineering insight we can take from here is that, like just now I said, we have to like begin with a strong general purpose model. Let it solve your problem, and then we should think about refining later. So this prevents premature optimization. So we should not think about optimization in the first step itself. First step is building something which works. Then we should optimize. That's the idea. Okay, now we will be discussing the tools. So tools is the execution layer of agents. So we know that the model, it interacts with the tools. Tools is like the external systems, and tools are responsible for performing the real world actions. If I talk about the examples of the tools, we can have API calls. Now this can be an internal API call, like it can be calling your own organization's ERP, CRM, something of that sort, or some third party APIs we can call, database queries, calculators, some functions, search engines. This is very powerful, like because model LLM cannot search. So to search engine, we have to do the crawling as a third party tool. Code execution, all that will be done by the tools. So why tools are necessary? Because models, they cannot act, they cannot access the live data, they cannot change systems, they cannot execute transactions. They can give commands, but we need tools for that, for executing transactions, for retrieving information. So that's why tools plays a very important role in agent systems, designing agent systems. Tools give agents agency. Tools make it agency, intelligence agency. Agents, the model LLM give the intelligence and tools give the agency. Without tools, agents are like just advisors. They will just advise. That is what we are using. Like the chat GPT is an advisor. It cannot act on behalf of us. Or Gemini, it's an advisor. But with tools, it becomes an agentic AI application. It becomes operators, wherein it will not just advise, but it will also act in the real world. So tools are very important. Okay, so designing capabilities for specific tasks. Okay, now like this is very clear to us that agents should not be general purpose by default. Large language model is general purpose. Like large language model, whatever you ask, it will give you the correct answer. But agents cannot be general purpose because agents are goal driven. So every agent is busy in accomplishing a goal. So whenever we are designing agents, we have to start with the goal in the mind. That okay, this agent I am designing, what goal it will accomplish. So agents should be designed for specific tasks. So this is very important. Then only we will achieve somewhere. Goal is very important in agent systems whenever we are designing agents. So the process is identify the target task, the goal we want to accomplish, and we should also consider breaking into subtasks. Like okay, a big goal we want to achieve, we can break it into subtasks. Then identify the required skills and map each skill to the tool or reasoning module. Because here, as developers, first we have to arrange the tools. Because if we are building a agentic AI application, first we should be very clear that okay, what tools it will use. So first we have to plan that okay, this is the goal I want to accomplish. This goal I can break it into three parts. Now this subtask will need this capabilities. So I'll identify the skills and based on that I'll identify the tools. So I will have a toolbox, and then it will be very easy for me to orchestrate. Orchestration will become easy because right tools will be there with me. So that's the idea. So here one example is there, like the task is cancel order, because the agent we are trying to build, it can accomplish three tasks, either refund, cancel order, or one more task was there. So three tasks was there. So if I take cancel order, now cancel order I can break it into subtasks. Like first is the understanding intent. So to understand intent, I need NLP capability, natural language processing reasoning capabilities, and hence the tool can be LLM also or any other model which can understand the intent. Extract order ID. To extract the order ID, I need parsing. I have to parse the order ID. To cancel order, I have to call the cancel order API. So I need that API tool. Send message, text generation capability. mapping is there, like I am designing the capabilities for specific tasks, then it will be very structured and easy for me to organize the things. Okay, now we will discuss tool integration and modularity. So once we have identified the right capabilities, the right tools we want, now for orchestrating, we need like tools. It might be they will be communicating with each other. So like tool integration and modularity. So agent systems should be modular, not monolithic. So this is very important. So individual components, they should be independent. They should be communicating via interfaces. And if we replace also, or if one component does not work also, the system should keep on running. So that is the advantage we get from modular design. So modular design is like if individual components, they are very flexible. If one component I remove, very easy reconfiguration I can do. So that is, so we call it plug and play architecture. So I did found out the tools I want. Now when I will be integrating the tools in the agentic AI application, it has to be a plug and play architecture, wherein all the tools, they will be communicating with the LLM, the agent system, and it should be very reconfigurable. Like tool B should have nothing to do with tool A. Like intercommunication we have to be very careful. Like dependencies we should not have. Like all tools should work independently. That's very important. Then very easily we can plug and play new tools. We can replace some tool, it became obsolete, we can replace it with a new version. So system will work very smoothly. So plug and play architecture for tools is very important. It will ensure flexibility, scalability, maintainability, and faster iteration. Okay. Now interface design. So the idea is that to communicate with a tool, we will be needing interface. So good interfaces allow tools to be swapped without rewriting the agent. And that's very important. Like we don't want major changes to be done. Like if I want to add a new tool, I want to replace a tool. And the good thing is that that's why we use framework. And that's why whenever you are building agent AI application, it is advisable to use a standard framework. Like LangChain is a very popular framework. And in that, everything is there. Like plugging a tool is a plug and play architecture because that framework takes care of this design pattern. So that is the thing we will achieve. So bad design, like if the agent code is directly tied to the payment API, then anything you have to do with the API, any upgradation, you have to change in the code. So that's a bad design. So the good design is that to communicate with the payment API, we have a payment tool interface. And agent is communicating with the payment tool interface. So any changes we have to do in the interface and not in the agent code. And that is a good design. And the framework, it takes care of all this. So that's something very useful for us. So the insight we should take away from this: hard-coded tools create fragile agents, because if a tool changes, the whole system breaks, and that is very bad because we are using third-party tools. Third party is not in our control. Any API tomorrow it might not work. So modular tools allow changing without chaos. So that's the idea. Okay, now we'll discuss the next component. That is the memory, the context engine. So memory plays a very important role because we already saw that LLM, it cannot remember anything. Every time we have to supply the context to it. The previous interactions also we have to supply it in the prompt. Then only it will take that into consideration while generating the new response. So memory, it enables agents to retain information across interactions and reasoning steps. So without memory, agents will just forget context because the LLMs cannot remember anything. They will ask repeating questions. They will just clarify, and they will make inconsistent decisions. So in prompt engineering, context plays a very important role, and hence in agentic AI systems, all the interactions we have to store in memory. So that we call it like the context. So two types of memory we deal with. One is the short-term memory that we also called as the working memory. It is the session memory. It stores the current conversation, temporary variables, intermediate reasoning results. So all that is stored by the short-term memory itself. It allows agents to maintain conversational continuity. For example, user sends an intent that cancel my order. Agent will decide which order or ask a clarify question which order you are talking about. User will tell the order, the one from yesterday. Now, if we are storing the context, then very easily LLM can find, because and without short-term memory, it will get confused. The one from yesterday, it does not know. So context plays a very important. Also, the session, the interactions we are doing, it is stored in a short-term memory itself. Because when we are designing an agent system, model is there, tool is there, and memory is also there. And in the memory, we have short-term memory and we have long-term memory. Long-term is something which is persistent knowledge. It stores information beyond a session. For example, user preferences, past interactions, history, domain knowledge. So if we look at an example from the chapter, an e-commerce recommendation agent must store purchase history, preferences. And this is something which we can get from external source also. Long-term memory, persistent knowledge we can get from our organizational database also. So that can also act like a context. Because let us suppose we are running an e-commerce platform wherein we are tracking the user behavior, the shopping behavior. All that record is getting stored in the database itself. We can use it as the context to our recommendation agent. So that is the persistent knowledge, the long-term memory. Okay. Now the so memory management and retrieval is very important. So memory systems, it must store efficiently, retrieve quickly, filter relevance, remove outdated data. So all this we have to take care. And the good thing is that framework, it takes care of most of the things. But still we should know why this is hard. So now memory management is not easy because once the memory it scales up, it keeps on growing. Lag, we will see lag, like retrieval will become slow. Noise might be there in the data, in the context, irrelevant context, higher cost of managing large memory. So the goal is to avoid memory clutter. Agents must sometimes forget. This is very important. It's not like always we just have to keep on storing, dumping. We also have to remove outdated data. Agents must forget also. Outdated knowledge, we have to remove it from the memory to avoid memory clutter. Irrelevant history, we should remove it. Context overload, we should remove it. Old preferences should not override recent behavior. This is something very important when we are designing AI systems. We live in a very uncertain world. Interestingly, most of the machine learning and deep learning models, which were exceptional before COVID 19, which showed very good results after COVID 19, they started failing. Why? Because COVID 19 was a global reset. All the behavior, all the patterns, all the trend, it got reset. So whatever the learning the model carried, it all went away. So change is something which we should keep in mind, and hence the word is evolving. So we should be well prepared that we should keep on watching that if the model is not performing well, something is wrong with the context, and we have to keep on refining the context. That is very important. So good memory systems are selective, not exhaustive. So we should not make the memory exhaustive. The context should not be exhaustive. It should be selective. Only the important stuff should be there, which is relevant. That's the idea. Okay. So I think we can keep it till here. This I think we can discuss in the next session. Because sir wanted to like have last 10 minutes.
Okay. So
Yeah.
designing a system orchestra. So this is the one, the I say the point that you want to keep for next session.
Yeah, this and two more like multi-agent architecture and the code.
Oh, and they are part of the chapter two only, right? I didn't read it completely. I was going on the way. I could not finish it as okay. Yeah,
Yeah, yeah,
let me
yeah.
share my
Chapter
screen.
two. Yeah,
So let
yeah.
me share my screen and let me know if you can see my screen. Okay. So please let me know once you can see my screen. Okay.
Yes,
Yes, we
visible.
can see the
We can
screen.
see that. Yeah. So this is the one of the the framework that I'm using in my project and in my internally with my team. Some discussion was going on. So after that, decided okay, let's use this agent. This is the framework. So it is called the Agno. Okay, and if we follow this guy, he keep on updating. Okay, Agno framework found for you and yeah, this is one Indian guy. His name is Twitter Asprit CEO Agno Infrastructure. Okay, you can follow. I mean, I am following him on Twitter, and he keep on updating. What is going on. Okay, he's I believe New York based. Okay, so the what about the beauty of this framework? Just to understand that why this framework is so. I attended last week some some conference, not conference, say some kind of the conference from the Google and other things. So what the thing that I observed, like so LLM, everybody they build their own LLM. Along with that, to use the LLM, we need some kind of the wrapper or framework, right? We can build the agentic application so that we can use the AI. Okay, so what is happening with this vendor? Either it is Microsoft or whatever, Google, or let's say Google or the Open AI, they build their own model, they expose their own API, and now we need to build the framework. So what they are doing their own framework. Okay, most of the time, like they are promoting their own framework. Like Google is promoting their own framework that is called Google ADK. Okay, so if you go to the Google, the technology and Google ADK, like so this is the the link for that Google ADK framework. If you go and you will get to know what is the Google ADK framework. Okay, same. So the Google did it on. Okay, and the Open API, they are providing their own the API Open API documentation. Using that, you can also build the agent. Okay, and there and one more like AutoGen given by Microsoft, they build it. Okay, but when it comes like if you are using one vendor or one model, if you want to use it, you are stick to them, right? So but there should be some kind of the something there we can switch, and it can kind of the so superstore kind of things, that if you need to change the model or if you need to switch to another vendor, you should have that flexibility. That's how this framework came into the picture. So Langchain was the initial framework, then initially that's a kind of open source, not the open source, but the common framework that all the different model you can use. So this is also there. So because this is the landscape is still evolving. So Langchain was kind of old, it became old. So this one is currently the hot, like it's fast. A lot of the advantages are there. So using this one, people are building the people are building the agent. Okay, and I just going through the documentation on it. So in my current project I'm using this. Okay, and if you follow the documentation, okay, so still we have the format on high level. I can tell that how is look like and this one. Okay, so if you as as we were saying, like that he and then Nukul was telling in the starting, when you are building the agentic application, then need to set what it is the workflow, or the what how you need to decide and which framework you need to do. Okay, so recently I was just doing the research on this one, so then I get to know one some fundamental, my own fundamental, I can say. Okay, and so this is like when you are building the agent, okay, AI application. So on high level you can keep, my screen is visible. If not visible, let me know. Okay, it may go
Yeah,
down.
it just
Okay, it may go down. Okay, something is there. I keep on sharing it. Okay, so what is that, like when you're building in any agent system. Okay, although I'm not moving, so if I'm not able to share my screen or something, then let me. So what the thing, like if you are building the agent, then high level, what the thing you need get to know, like how much AI you need to use. So I came to the use cases like agent where more AI is there, more AI, where open-ended scenarios are there, just like that's a high level question. Okay, summarize me this book. Okay, and publish, do me some research. So where these are the open-ended question, open-ended scenarios, right? You have the open-ended, you don't know. Just like the same thing apply, like you give one book, just like in our book to a class or in our group, like everybody reading the book. Okay, the book is fixed, but if you ask everybody to summarize it, everybody will come up with the different line here and there, but they are related to it, but they are not fixed. Okay, so there, that's where the open ended, where the more AI need to use it. So that's where you will use guys more agentic fun. Okay, something are the some kind of the workflow. So this framework also improve the workflow, where you need to use 50% AI, 50% more in predefined logics are there, so there you can use it. Third one thing that in my project that I get to know, okay, this is the best scenario for, they call the custom agent. Custom agent, this is like where you have the less AI, but the more of the already predefined codes are there. So just like in the designing he was mentioning it, I can correlate with my cases like where already I predefined the functions, predefined methods are there, predefined tools are there, they will do the work. Only I need to identify the intention, like in my case, like they send the email, they want me to track a file, they want to send me the email, they want to download the file, or they want to generate some report. So based upon those email or the chat, I go through execute some functions. Now whatever I am doing, that will be done by AI. So it just identify the intent. Once I identify the intent and identify what is written inside the text, then I can go and execute rest piece of the code. Okay, so these kind of things. So if you go to this framework, like on high level, this framework introduce 2 3 things. Okay, it tell agent, like when they are defining the agent. So where if you see the agent class in this framework, the agent come from this one. Okay, agent is their class, from there define the agent, and that there you need to pass the model. Okay, here you can pass any model, it does not matter which model you are passing it. Okay, like any model instance, like a OpenAI model, a cloud model, whatever, that is how they are passing it. After that, they are the tools. Okay, that which tool you want to pass. So tool is just like the function they have written, the full is a normal tool. Okay, that whatever you write it. After that, you will add different options to it. uh, Somebody
Yeah,
is raising.
Mohan, one question actually. So, what I understand is that this Agno framework, it
Mhm.
replaces LangChain LangGraph. Right?
Yeah,
Just
right.
like
It is
using
alternative.
LangChain LangGraph, you can build model.
Mhm.
You can use, instead of that, you can use Agno.
Yeah, so you can same thing. You can do the the LangChain, LangGraph, and but you can use this one as well. But this is having
Right.
the more facilities, and it is bit it is bit it is bit advanced. Okay, that's the thing. Okay, so if you see it is provide the agent, you can build the team, different agent workflow, and it provide agent OS as well. So agent OS is nothing but kind of the UI. Okay, see the UI is there, where it will, if you run it, it will expose you some kind of the UI there one there one a chat kind of windows will come, you can interact with that. Okay, these kind of the option it provide. So on high level, agent workflow just like as I saying, the predefined task. Agent means some particular, team means multiple agent you are clubbing together. Okay, and the agent OS is the UI. So if you go to the documentation of this one, these are the whatever he covered in the, everything is there. um yeah. Yes, anyone has any question?
Yeah, Akhil wants to have a question.
I just want to know, is it like open source or we need to
It
license
is
for?
open source. It is open source. It is open source. You nothing, just like when you install it, like you can install it, like, so I can show you one thing, one piece of code. Okay,
Okay, thank
that
you.
I was just doing the POC. I can show you that how you just need to install a library when you say the start. Okay, let's say the first agent when you build it, just like it's simple, like you go to one, you create a project, and you install this dependency like Agno dependency, Open API, Scrami, and Chroma DB, some dependency you can install it, right? It is just to call the Open API. It is this framework. These are the database to store the memory and context. Okay, that whatever you discuss it. After that, you give your one and create a model and start working on it. Okay, so if you see my piece of code, right? If you let me know if you are if you, my screen will go. Okay, so let me know, don't see it. Okay, so this is a simple POC I is doing, and just to depending different things, like so you created an agent database where you store the memory or something like that. Whatever we are discussing now, you need to store the memory, and then you need to create just like a simple agent, we build it. Okay, this is what for POC. Although actual one I am different, like you get the model from you get any model based upon your convenience. Okay, how you get the insight, then you get token, this one just to get the model. Here the piece of code are there, where you will give the name agent, you will give the model, and you will give the the memory and other things, you can do it, and you start playing it, it start giving the one. And agent is, it will a UI, it will generate, and using the UI it will display. If I will say like this, let me see how it is running, if it is run, if it don't have. But if you go inside the different documentation of it, go to the side and see the different documentation, everything is mentioned in this Agno framework, like Agno These are different, for agent, API, cloud, culture. Okay, it is having the culture, integration, knowledge, memory, model, reasoning, registry, remote. Whatever we discuss in the design pattern, all the concepts are there. Even more than that is there. What the guardrail, hooks, knowledge, culture is the new things I get to know. Other than session, skill, team, different workflow, vector, DB, try everything is there. If you go through the documentation, and you will get to know everything. So the time is up. Okay, so you can explore this one. You can read it, and typing, and next session, like we can deep dive it. I already gone through the documentation, most of the
Yeah,
pieces
next
I
session
already.
you can also, yeah, that's fine.
Okay. So
I have one more question. जितने फ्रेमवर्क जैसे हैं एडी आपका गूगल एडीके हो गया या एग्नो है जो कॉमन वेरी कॉमन और रिपीटेबल टास्क है फॉर एग्जांपल वी वांट टू सेंड अ ईमेल राइट और वी वांट टू लुक अप सम आरडीबीएमएस
mhm.
इन आवर network. So for such tasks, are there any like reusable tools that we can use out of the box available, or we have to write everything from scratch?
उसी से मैं बात कर रहे हैं। आप ऐसे देखो, आप केसेस देख लो। देखो, जैसे बोले गूगल एडीके वगैरह इसको यूज कर सकते हो, तो सिंपल ये टाइप का ये कॉस्को टाइप है, ठीक है। देयर यू विल फाइंड द ऑल द डिफरेंट मॉडल, और जो कॉमन चीज है कि दूसरे मॉडल के साथ गूगल एडीके की बात करोगे तो गूगल की बात करता है, उनका अलग सेंटर है। ओके, okay, okay, sure. I can share it, and but I'm on the same screen only. I'm not moving it, but I'm just answering the question. Okay, thank you. So, key. So it is just like you can do whatever is just like a common in the place of the lang chain. You can use it. If you are using the lang chain, use this one. Okay, first thing. So Google AD. So concepts are same. Whatever the concepts are, I was showing you, right? If you go to the documentation, okay, once, okay, this documentation, all the concept mention it. If you go to this documentation, these are the concept. They are the common across all the framework. Either it is the LangChain, or it is the Google ADK, or it is the Agno, or any other framework. They are all the common concept are, and whatever we covered today, like what the memory होनी चाहिए, क्या होना चाहिए, टूल कैसे लगाना है, डिजाइन कैसे करनी है, गॉड रेल कैसे करना है। दीज आर द, इफ यू गो वट एवर वी आर गोइंग टू कवर, ऑल आर द कॉमन कंसेप्ट, एवरीथिंग कॉन। एंड आंसरिंग टू योर क्वेश्चन कि ईमेल वगैरह भेजना है तो कुछ क्या करना है। ओके, फॉर दैट व्हाट यू नीड टू डू इन नेचुरल लैंग्वेज, कि एक ईमेल भेज दो इस बंदे को, दिस इज द वन थिंग। ओके, एंड यू कैन पुट दिस इंटेंट, ओके, द यूजर टॉकिंग अबाउट टू सेंड द ईमेल, ओके, एंड दिस इज द सब्जेक्ट ही मेंशन, okay, and here you want to send the email. All these things you can capture using LLM only, because natural language को पैरामीटर में कन्वर्ट करना है। एंड हाउ यू विल डिजाइन इट, लाइक यू रीड इट एंड अटैच टू ए प्रॉम्प्ट, और प्रॉम्प्ट के बाद जो आउटपुट आए ना, उसको क्या कर देना है, एक आउटपुट है ना, ठीक है, आउटपुट के साथ उसको फिक्स कर देना है यूजिंग पाइडेंट स्कीमा। अब तुम्हारे पास इनपुट मिल गया और आउटपुट आपका फिक्स हो गया, उसके आगे का पीस ऑफ कोड ट्रिगर कर दो कि तुमको ईमेल भेजना है। आई एम आल्सो सेंडिंग द ईमेल फ्रॉम माय वन ऑफ द प्रोजेक्ट, राइट। ओके, कि मेरे को ईमेल मिल गया, सब्जेक्ट मिल गया, बॉडी मिल गया है, और उसके बाद आगे का फंक्शन एग्जीक्यूट कर देना, इट विल गो सेंड द ईमेल फॉर मी। इट कैन डू एनीथिंग, इट्स लाइक
तो
एपीआई।
जो फंक्शन है जो कि ईमेल सेंड करेगा एक्चुअली दैट फंक्शन इज पार्ट ऑफ द फ्रेमवर्क और एलएलएम
फंक्शन वो तुम्हें खुद लिखना है, वो फंक्शन और इंटीग्रेशन तुम्हें खुद लिखना है।
खुद
फ्रेमवर्क का
लिखा
पार्ट केवल इतना है कि आपको करोगे। और ये सारा कोड पता है कैसे होगा, ये कोड तुमने अलग अलग पाइथन कोड ये सारा लिख दिया। अब तुमको क्या करो, उठा के इसकी एक डॉकर फाइल बनाओ, और डॉकर फाइल को उठा के डिप्लॉय कर दो क्लाउड में, कहीं पे भी जाए मन करे तुम्हारा, बस छुट्टी। जैसे द मोमेंट यू विल स्टार्ट इट, ठीक है, जैसे तुमने स्टार्ट किया, ठीक है, वो रन होना शुरू हो जाएगा। फिर जैसे ही तुम आप कुछ टाइप करोगे, तो जहां से पहला वाला इनपुट एजेंट को आएगा कि भाई मेरे को यहाँ पे पहुंचाना है उसको, ठीक है, यू कैन कॉल दिस एजेंट। तो एजेंट कॉल होता है, ऐसे कैसे होता है एजेंट को, कि एजेंट डॉट, अगर तुम एजेंट का नॉर्मल फंक्शन देखोगे किसी को भी, तो एजेंट डॉट रन होता है। वो किसी फंक्शन के अंदर रैप कर दो एजेंट को, और वो वाला मेथड में जो तुम्हारा टेक्स्ट था उसमें डाल दो, आगे का अपने आप को कर लेगा, उसके रेस्पॉन्स से दूसरा फंक्शन कॉल कर दो। ओके, दैट यू कैन डू इट। ओके, इफ आई शो यू वन मोर पीस ऑफ द कोड, ओके, आई कैन शो यू दैट। ओके, दैट विल बी बेटर एग्जांपल। ओके, कि जैसे ऐसे ये वाला पीस ऑफ कोड है, ठीक है, ये वाला नहीं, मैं ये वाला लेता हूँ, ठीक है। ओके, इफ यू अदर कैन, इफ यू वांट टू, आई एम जस्ट ओपनिंग, सी, सिंपल वन,